Welcome to video 6.4 on the limiting reactants. In this video, you're going to understand the concept of the limiting reactant. And then we will also look at how to calculate different type of limiting reactant problems. So as we get started, there's only one key vocabulary term you need to know. That's limiting reactant. And yes, you will need your mole map, periodic table, and of course the video notes. Go ahead and grab a pencil while you're at it, and let's get started and re-enter the wonderful world of stoichiometry. So as we get started, we have to remember that life typically comes down to money. When you look at the commercial world or the industrial world, we want to be cost effective. We want to save money. And so what we're going to do is we're going to do calculations to look at how much reactant we actually need to produce a desired product. We don't want too much of this or that because it's just wasteful. And so what we do is we look at what's called the limiting reactant. So whenever you see the phrase limiting reactant, that is an opposite to the phrase excess reactant. So what we're going to have is something called the limiting reactant, and then sometimes you'll have the excess reactant unless the two reactants are in equal proportion. So here's a scenario. We have hot dogs and buns. We see we have 1, 2, 3, 4, 5 hot dogs, and we have 1, 2, 3, 4 hot dog buns. So when we look at this problem here, we know that one hot dog will go into one bun. And therefore, you can make 4 hot dogs and buns, and you'll have one leftover hot dog. This is a situation of where we are not being cost effective. We spent too much money and we bought more hot dog than we actually needed. And so here's a situation where we can identify what our limiting reactant is or our limiting reagent. And we can also identify what our excess reactant is or our excess reagent. So in doing these problems, all you're going to do is you're going to do 2 stoichiometry problems, and you're going to predict the product from 2 starting points. So what you would say is, from this situation, if I have 5 hot dog buns, if I had 5 hot dogs and I had unlimited amount of buns, I could in theory make 5 hot dogs. But if I start from the buns position in the scenario B, if I have 5 buns, I could only make 4 hot dog with hot dog buns. And so from here, I could predict I can make 4. From here, I could predict I can make 5. And so therefore, the buns makes less product. This is how we would identify our limiting reactant. So again, all we're going to do here is we're going to convert both of our products to the desired, both of our reactants to the desired products. And then whichever reactant produces a less product, we're going to identify that as our limiting reactant. So the only thing that really trips kids up here is having to do 2 stoichiometry problems at once, which makes people a little nervous. But keep the big picture in mind. All we're doing is doing 2 conversion problems, and we're predicting one product from 2 starting points. And then whoever produces the less amount of product, we identify that as our limiting reactant. So let's get started. So here's practice problem number 1. You can watch me do this, and then you'll get a chance on the next one to try it yourself. So here it is. If I have 4.95 grams of ethylene, which is just C2H4, and that's combusted with 3.25 grams of oxygen, the question is, what's my limiting reagent and how many grams of carbon dioxide are formed? So like I said on the previous slide, all you're going to do is do 2 stoichiometry problems. But in order to keep this straight, I'm going to show you how to write this out to keep your conversion problems straight and you know what you're doing. So as we do this, the first step we need to do is we need to write out our chemical equation. So I have ethylene, I'm going to write up here, C2H4, reacts with oxygen, and we should know already that that's a diatomic, and it's going to produce what you know from last chapter, that this is a combustion reaction, and it'll always produce carbon dioxide, and you can say it with me, water. So as I get going, I can't quite start yet because this is not balanced. So I need to go through here and balance it. I got 2 carbon, so I need to put a 2 here. Now I have 2 hydrogen and 4 hydrogen, so I need to put a 2 here. So now that gives me 2 oxygen plus the 4 oxygen, which means I need a 3 here. So now here is the step I want to show you to kind of keep this straight. Whenever you're doing a limiting reactant product, or when you do a limiting reactant problem, I like to call it scenario A and scenario B. What this does for me is it keeps my conversion problem straight, because we're going to do a lot of problems here and you're going to get kind of messed up. And so this is like your overall picture of what's going on. And so I like to set it up with the fact that it says 4.95 grams of ethylene. We're going to put that right here and say 4.95 grams in scenario B. And from there, we're going to predict how much carbon dioxide will form. And then scenario B, with 3.25 grams of oxygen, we're going to again predict how much carbon dioxide. So you can see here that in my situation, I have both of these starting points, but I create scenario A and B, so I can see that I'm going to predict two different amounts of carbon dioxide. This amount will be predicted from this starting point. This amount will be predicted from this starting point. So now when I go down here to do my problem, I just want to keep it straight, and we're going to do a conversion problem, and we're going to convert from C2H4 all the way to carbon dioxide. So if you remember on your mole map, what we are going to do now is we are starting here in grams of one thing, and we're going to convert it all the way to grams of something else. And we're going to do this conversion problem twice. So as we get started, I'm going from grams, follow my units, C2H4. I know again from my mole map that if I'm in grams, the only place I can go to is mole of the exact same chemical. So we go to mole of C2H4. We'll come back and get that number in a second. Follow my units again, mole of C2H4, mole of CO2. Again, now on your conversion map, you're here, you're converting to here. So we use the mole ratio, which is just the coefficients. So my coefficients here tells me one of these produces two of those. One of these produces two of those. Follow your units again, mole of CO2. Now that I'm in mole of CO2, I'm going to convert it to grams of CO2. And again, how do I find these values here? Well, we can do it off to the side, but I know carbon is a 12.01 grams. I have two of them. And then I have four hydrogens. And in my head, I'm going to say 4.044. So total up, that's going to give me a number of 28.06 grams. That goes down here. Over here, same thing, 12.01's carbon plus 32. That's going to give me a 44.01. That goes here, and yada, yada, yada. We have our problem set up. Now that is scenario A. So if I do my calculator, I'm going to go 4.95, multiply by 1, multiply by 2, multiply by 44.01. Divide now by 28.06, divide by 1, and you're going to come out to a number of 15.527. 3 sig figs means I have 3 sig figs here. Go and label it carbon dioxide. So we said from this starting point, we're going to be able to produce 15.5 grams. So in scenario 1, from this starting point, if I had unlimited oxygen, I could produce that much product. Now we have to do scenario B. If you're feeling comfortable, go ahead and pause the video, try this yourself, and see if you can finish out the last two problems. If not, I'll show you how to do it, and there's another practice problem for you guys to try. Okay, scenario B. Starting point, 3.25 grams of oxygen. Set it all up, follow your units. I know from grams of something, the only place I can go is the moles of that same something. Again, oxygen's 32. We can look on our periodic table, do that one quickly in our head. Follow our units. Now that I'm in mole of O2, I want to convert to mole of a different chemical. That different chemical is going to be from mole of oxygen to mole of carbon dioxide. And I see again, 3 to 2 is my ratio. Now we got to finish it out. Go to grams of carbon dioxide. And again, just like before, it's 44.01. Now we're going to throw that in the calculator. We got 3.25 times by 1 times by 2 times by 44.01. Divide by 32. Divide by 3. Divide by 1. And again, I start with 3 sig figs, so my answer needs to have 3 sig figs. So again, what we did was we calculated the mass of carbon dioxide twice. We said from this starting point, we could produce that much. From this starting point, we could produce that much. So now we can go answer a question. What is the limiting reagent? Well, from here, I can only make that much product. With 4 hot dogs, I can only make 4 hot dog sandwiches. From 5 buns, I can make 5 hot dog sandwiches. So since this is making less product, this would be identified as our limiting reactant. I like to label it there, but then of course the answer is here. And then go down here, how many grams of CO2 are formed? I can't make that much. I don't have enough of oxygen present to make that much carbon dioxide. So my answer is right here. We would actually make 2.98 grams of carbon dioxide. Hopefully you can see that the concept of a limiting reactant versus the excess reactant is not complicated. It's just doing the stoichiometry and keeping the big picture in mind. All right, let's try another problem now. So on this other problem, we have the chemical equation already written out for us. However, there is a small typo here. There should be a 3 here that I left off on the note. So go ahead and fix that real quick. So as I look at this problem, I gave you the balanced chemical equation already. And then I ask if 35.60 grams of sodium hydroxide is reacted with 30.80 grams of hydrogen phosphate, how many grams of sodium phosphate are formed? And then also, what is my limiting reactant? So in order to get this problem set up, let me show you again how I would do it. I would write up my chemical formula. I would create scenario A, and I'd create scenario B. And I would say, okay, from this starting point in scenario A, we're going to have 35.60 grams. And from that, we want to predict how much sodium phosphate. So I'm going to put a question mark here. From scenario B, from this starting point, we're going to try to find again how much of this we would make. And so now we were going to do our 2 conversion problems. Go ahead and try to pause the video, practice these conversion problems on your own, and see if you can finish out these answers. If not, you can watch me and you'll get tons of practice in class. All right. So I want to know first how many grams of this product I'm going to make. So I'm going to convert from here to here and then do a second conversion problem to convert from here to there. And whoever makes less will be how much I could actually make. So here we go. 35.60 grams of sodium hydroxide. Sorry, let me go ahead and label this as scenario A for you. Okay. We're going to follow our units. Mole of NaOH. Now I'm going to follow my units again. Mole of NaOH. Again, we just went here. It's going from here to here. Now I'm here, and I'm going to go to moles of my new unknown product, Na3PO4. And since I want to finish it in grams, I got to follow my units one more time and go to grams of Na3PO4. All right, so now, how do I fill in these numbers? Well, first of all, this is my molar mass, and so I did the work down here already to save us a little time on the video. So again, the molar mass of sodium hydroxide would be 40.00 for every 1 mole. My coefficients dictate this conversion factor. It says 3 of these will make just 1 of those. And then my last mass here is found down here. 163.94 is 1. And then again, I can go through and do that on my calculator. 35.6 times 163.94, divide by 40, divide by 3, and we should get 4 sig figs. So my answer should have 4 sig figs of 48.64 grams of sodium phosphate. Again, you started here and you just predicted the amount you would make, and according to this situation, according to scenario A, we can make 48.64 grams. So now let's do scenario B. Again, feel free to pause the video if you have some confidence, but really you need to try this yourself, and it's just about practice at this point. All right, so starting here, 30.80 grams of H3PO4. Follow your units. I can go to moles, H3PO4. Follow my units again. We were here. I converted from grams to moles. Now I'm going to convert from moles to moles. Convert from moles of H3PO4 to moles of Na3PO4. And then follow your units again. Mole of Na3PO4 to grams of Na3PO4. Now go back in, fill in my numbers. H3PO4 is going to be 98.00. Conversion factors here comes from the 1-to-1 relationship. And then here on the bottom here, sorry guys, 98 goes there. 163.94, again, came from your periodic table. Put that in our calculator, and it would come out to 51.52 grams. So again, from this starting point, you're going to make 51.52 grams. So the question that we started with, how many grams of sodium phosphate can you make? You can't make 51 grams. You don't have enough of this to make that. So we're going to say the lower amount is simply going to be the amount we can make. So this would be how much we can make of Na3PO4. This is what we would call our theoretical yield, right? And then now the question is, who is your limiting reactant? Well, this is going to be my limiting reactant. This is going to be my excess reactant. Why again? Why is this my limiting reactant? Because he will be predicting to make less. He determines how much product we would make. So again, I would answer the question as sodium hydroxide. So I know these problems look sick and nasty, but really it's an easy concept of just taking an amount and predicting the product. Taking an amount, predicting the product, and whoever is less is how much you can actually make, and whoever is less tells you who your limiting reactant was. So as we wrap up this video, I hope you will see again that a limiting reactant just shows you how much product can actually be made. What we're doing is we're just doing 2 stoichiometry problems to predict 2 amounts of the same product. Whichever value is less is the correct answer. And again, the reactant that produces a lower amount of product is defined as the limiting reactant. Have a wonderful day, and I'll see you in class.